Hi, I'm currently doing Paul McWhorter's Arduino Uno R4 Wi-Fi lessons, and we're currently on lesson number 4, but I'm going to be away, so I thought I would preempt what I thought was the homework for lesson 5, which is to create a binary counter from 4 LEDs. So I've got 3 solutions that I'll go through quickly. The first solution is using direct port manipulation that I showed in my homework for lesson number 3, and this will only work with the R3 as opposed to the R4, but I will be changing it round sometime, and it's all very simple. You can just set you could just loop round, and from 0 to 16 you can just set all the ports as you want them. And to prove that it does work, I know it's flashing, but just to prove that this does work, and it uses logical ORs and logical ANDs and things, and there we have it, it's working, you can see. Right, my next solution, which is this one will work on the R4, which is lucky, but I don't have a cable for it at the moment, my cable's broken. Right, all I'm doing here is I've set up the pins, and then for I to 0 to raise to the number of pins, which is 15 inclusive, I'm just working out the whether digital pin wants to be on or off, because I'm taking the number, I'm dividing by 2 and taking the remainder, which is the right hand pin, and then I'm dividing by 2 again, and then that's the remainder's the next pin, next pin, next pin. All very simple, but that's one way of doing it. And then my final way is the one that I'm actually quite pleased with here. My final way is that what you can do is you can do a digital write. Stop it. You can do a digital write by using the previous state of that pin. So if you want to toggle it, you could go that line there, line number 18, digital write, digital pins. But the reason why I'm doing this is, I don't know if anyone will be able to see this. Right, when you're toggling, when you're doing a binary count, you start off with 0, 0, 0, 0. Now, if you toggle the first digit, it will go to 0, 0, 0, 1. Then, if you check to see if that digit that you've just toggled is 1, you don't need to go any further. You just go back. Now, the next time round, you go in there, you toggle the first digit, you check to see whether it's 1, and it isn't, so then you go on and you toggle the next digit. And then, because that's a 1, you come out. Then the same thing goes in, you toggle the first digit, and it's a 1, therefore you break out, so you're left with that. Next time through, you toggle the first digit, it's now a 0, so then you toggle the next digit, which is now a 0, so then you toggle the third digit. And this is kind of what you do when you're doing addition with a carry. So it goes right down to the bottom. Then the last one, if you toggle, the last one, if you toggle the first digit, that's a 0, so it carries on. You then toggle the next digit, which is a 0, so it carries on. Toggle the next digit with a 0, carries on. Toggle the next digit, so you're left with 4 noughts, and it falls off the end because you don't have any more digits. or LED states. So that is exactly what this program does. Stop it. You just go in, you find out, you read the pin state, and then you toggle it, and then you say, is it 1, which is shorthand for that, because digital read pins blah blah, it is true. Therefore you don't have to say equals 1 or equals 1. Then you break out, and once you go all the way through, you break out at the bottom when you've got to 5, 4, even 4, and then it goes around and does it all again. This is a great program, I think, but just to prove that it does work, yeah, it's still working. Hurrah.